Hey, I'm Ollie. Welcome to my presentation for Assessment 3 in Biomechanics. This presentation will assess and critique the use of the GPS technology in AFL. It'll cover its ability to assess an athlete's movements relative to AFL, including speed, velocity, distance, and acceleration. It'll outline what GPS is, how it's useful in the AFL, and some advantages and disadvantages. What is GPS technology and how does it work? GPS technology tracks positional data in sports by using signals from our orbiting satellites. A receiver calculates how long it takes for messages from each satellite to arrive and then computes their distance to accurately pinpoint its location. These receivers determine an athlete's speed and position with up to 1 metre accuracy. They work by triangulating signals from multiple satellites and are now used in many sports, including AFL. This data is processed to help understand work rate patterns and physical workload, with the accuracy often depending on the sampling frequency and the number of connected satellites. How has GPS evolved over time? In its early days, GPS technology grappled with signal interference issues, which were resolved around 2000. The initial GPS devices used for sports tracking were often very bulky, weighing up to 4 kilos, but their design has now become more streamlined. The introduction of enhancements such as the wide-angle augmentation system notably improved accuracy, with significant advancements noted in cycling. By 2003, GPS specifically designed for sports was introduced. Between 2009 and 2010, its accuracy and relevance in team sports were validated through various methods, though challenges persist, particularly during rapid velocity changes. The introduction of GPS in sports, including AFL, has revolutionised performance analysis, training regimes, and player health monitoring. It has enabled real-time and post-game feedback on player movement, allowing for better decisions to be made by coaches and staff. In the AFL, GPS has been used to tailor training routines by analysing the distance players cover at various speeds. GPS aids in correlating fitness tests with actual on-field performance and helps determine energy requirements for different player positions. What biomechanical movements can GPS provide data on? The GPS unit for AFL players is a wearable device that goes in a pocket on their upper back of their sports vest. GPS can provide data on a range of movements, including speed, total distance covered, sprints, changes in direction, velocity, and acceleration. The GPS is able to measure speed by measuring the athlete's change in position over time, without taking into account the direction of the movement. Total distance covered refers to the cumulative distance an AFL player travels across the field during a game. This includes all types of movements, including running, jogging, walking, and even sideways or diagonal motions. Because GPS technology gives us the capabilities to determine direction, we can also measure a player's velocity. Velocity refers to the rate of change of an object's position with respect to time, often described with both magnitude and direction, making a vector quantity. In AFL, understanding a player's velocities can provide crucial insights into their performance, agility, and fitness levels. GPS devices measures velocities by analysing changes in position over specific intervals of time. Accurate velocity measurements are vital as they not only assess a player's in-game performance, but also aid coaches in tailoring training programs, managing fatigue, and preventing potential injuries. GPS also gives us the ability to measure acceleration indirectly. It calculates your position at multiple times and uses this data to determine velocity at these points in time. By finding the change in velocity and dividing it by the change in time, the GPS can estimate acceleration. The reliability of GPS technology in tracking athletes' speeds varies with the velocity of the movement. Studies have shown that GPS devices are more reliable and accurate at measuring slower speeds, and become less reliable as the athlete's speed increases. This is likely due to the athletes covering larger distances at higher speeds, but the sampling rate of the GPS remaining the same. In evaluating GPS's reliability for tracking human movement, it changes based on certain factors. Earlier GPS technology showed significant variability. A 1 Hz GPS showed variability at 77%, but when switched to a 5 Hz GPS, that variability dropped by nearly half at 39.5%. Recently, improvements in technology have led to 10 Hz and 15 Hz GPSs being used, which have been shown to be even more reliable, valid and accurate for faster sports involving sprints and turns, such as AFL. Understanding the sampling frequency, or the rate at which the data is collected, is essential for evaluating the performance of GPS units in tracking athletes' metrics. Research has shown that 10 Hz GPS units are generally more reliable for measuring distance. Varley 2012 found that 10 Hz GPS units are significantly more accurate and reliable than 5 Hz units for measuring instantaneous velocity and running activities. The 10 Hz units were up to 3 times more accurate and 6 times more reliable. While some units claim to offer a higher 15 Hz or even 18 Hz sampling rate, it's important to note that this is often achieved by combining 10 Hz GPS data with accelerometer or gyroscopes information, a method that has not been thoroughly validated. In fact, a study from 2014 found that 10 Hz units were more reliable for measuring total distance than their 15 Hz counterparts. On the other side of this technology spectrum, local positioning systems, LPS, are designed for smaller, localized environments and typically offer higher sampling frequencies, such as 20 Hz, using technologies like radio frequency identification and ultra-wideband. Hop et al. 2018 found that even advanced GPS units, which claim to provide up to 18 Hz rates through sensor fusion algorithms, were outperformed by 20 Hz LPS systems in terms of reliability and validity, especially for critical biomechanical metrics like sprints and change of direction. Thus, for applications requiring high fidelity data in local environments like AFL, 20 Hz LPS devices appear to offer superior performance metrics compared to even the most advanced GPS systems. In sports with frequent substitutions like AFL, merely analysing total distance run or peak speed reached can be misleading. Players who are subbed out might exert more effort in shorter time spans when back on the field, and their overall statistics could appear similar to those who played continuously. To truly understand a player's workload, it's crucial to account for the time spent on the field as it impacts the intensity of their play when they return. GPS systems like Catapult are widely used in the AFL for real-time performance analysis. These units have evolved to include additional sensors like accelerometers, gyroscopes, magnetometers, and heart rate monitors. This multifaceted data collection allows for a comprehensive view of an athlete's performance. It monitors not only instantaneous speed and movement intensity, but also more precise and fast changes in direction and distance covered. Moreover, integrated sensors provide biomechanical insights, such as the force of impact during player collisions, offering valuable data for both performance optimization and player health. Benefits of GPS tech to stakeholders. The GPS technology in AFL may provide many benefits to other stakeholders, including fans, who can enjoy a more interesting and engaging game, where they can see in-game player statistics, which will in turn benefit the AFL business, with an increase in the fan base, leading to more profit. Coaches and medical staff have the benefit of the technology to manage their players and improve individual and overall team performance. While GPS technology alone has proven effective for tracking speed, velocity, distance, and acceleration, it can't capture detailed biomechanical data such as joint angles or force exertion. These gaps are beginning to be filled by integrating GPS with other specialised sensors such as the devices mentioned earlier. Doing so would offer a more holistic view of the player's performance, capturing nuances that GPS can't provide. Does GPS technology harm or enhance athletes' reputation? GPS technology may enhance athletes' reputation by showcasing their work rate, stamina, and commitment on the field. However, if not managed well, it might spotlight the underperforming players, potentially harming their reputation. Players may feel like they're under constant scrutiny, not just in terms of their performance, but their physical well-being, and this might also impact their mental health. Wearable technology in sports, like the GPS, raises privacy and ethical concerns. There is a potential risk of data leaks or misuse, especially if the data were to be sold or used for other purposes other than sports analytics. Transparency is crucial. Athletes should understand the data's use and always retain control. It's a balance between tapping into the health data's benefits and upholding athletes' rights. The cost of GPS technology in the AFL would vary significantly based on its features and quality. The league has partnerships with companies like Catapult, who supply advanced GPS units along with other high-tech devices. These trackers range from personal devices to large-scale corporate solutions, which would come with substantial contracts and require additional support for data storage and analysis. The adoption of high-end GPS technology, particularly those with higher sampling rates of 10 and 15 Hz units, would require significant financial investment. These costs would not only include the hardware, but also software subscription fees, staff training, management, and data storage. However, it's important to weigh these costs against the potential benefits. Enhanced performance analytics can lead to better player health management, tailored training regimes, and ultimately improved game performance, potentially translating to more wins and more revenue. Not to mention the indirect advantages like increased fan engagement through real-time player statistics. Therefore, from a business perspective, despite the expected steep initial costs, the long-term benefits could very well justify the investment.